Welcome, students. In this video we're going to look at the following optimization problem. What you see on the screen is a window here. This is the window here. It looks like a semicircle and a square here. So we're going to optimize it to find the dimensions y and x. And this type of window is called a Norman window. So let's optimize it. The way we do it is we find a general formula. Remember when we find, so let's see. We're gonna optimize the perimeter because that's what we need to find. We need to find those dimensions. So perimeter is gonna be equal to x times y plus half of, remember the what's outside the circle is called the circumference, and we only have half of it because this is cut in half. So we're gonna call it 1/2 times 2 pi r. That's gonna give you just pi r. Oh, actually, this is the perimeter. So we're just gonna do 2y plus x. Actually, we're not doing area yet. I was getting ahead of myself. So the perimeter, that's the perimeter, and the area. Now we do the area. The area is gonna be x times y plus half pi r squared. And what is r? Remember, here is x, so half of x, so that would be, so we're gonna do this one is xy plus 1/4 pi x squared. But when you multiply 1/2 x, so that's what this becomes 1/8 actually, because 1/2 times 1/2, that's 1/4, and 1/4 times 1/2, that gives you 1/8. Now we're gonna take that. Now we're doing the optimization. We're going to plug in. We're gonna solve for a variable, plug it in here, and then we're gonna optimize it. We know that the perimeter has to equal 32, so that is given. So perimeter is equal to 32, 16 feet actually, 16 feet. Okay, so let's see. Let's solve for y here. So 2y plus x plus pi. Remember r, we already know that r is equal to half x, so that would be pi over 2x and equals, and this is plus here, equals 16 feet. We multiply everything by 2 so to get rid of these 2, so that would be 4y plus 2x plus pi x equals 32. Okay, we solve for y, so 4y is equal to 32 minus 2x minus pi x. We divide by 4, so y is equal to 32 minus 2x minus pi x over 4. Okay. Remember, the bigger the window, the better we want, the better it is. But we need to optimize it. So we're looking for y and x. So here we just plug in our y and then take the derivative. So let's plug in. So after plugging in y here and doing manipulation, you're gonna get that the area is equal to 8x minus x squared over 2 minus pi over 4 x squared plus 1 over 8 pi x squared. Now we take dA dx. When you take the derivative, you're gonna get a minus x minus pi over 2x plus pi over 4x. Now we set the derivative. Now this is where we're gonna optimize it. So we set the derivative equal to 0, and you're gonna find that x is equal, after doing the calculations, you're gonna find that x is equal to 32 over 4 plus pi feet. So this is x, 4 over pi feet. 32 over 4 plus pi feet. And then your y is equal to 16. Or to find your y, you just plug it into here. You plug in your x and you get your y. So that would be 16 4 plus 15 feet. So these are the two answers that we were looking for. So notice, let me recap what we did. So first we find the perimeter formula. We go around the window. Then we find the area. The area is the area of the semicircle and the square or rectangle. We're gonna see what it is because we have to optimize it. So then we wanna have one equation that only has one variable, so we can take the derivative and optimize it. So we take the perimeter. The perimeter, remember, was 16 feet. So we set the perimeter equal to 16 feet. We solve for y, we get this. We plug it into a, and we get this. Now we take the derivative, we get this. We set the derivative equal to 0. We find that x is equal to this, and then the final step is just to plug in your x into here, and you're gonna get 16 over 4 plus 15 feet. That's it. Thank you very much, students.